Alright, so let's continue our discussion over modeling with expressions. So we're going to model each situation with an actual expression. Right, so this right here says you had $150, but you are spending $2 each day. So easily we have 150. We're spending $2 each day, and then the each day part, so each day could be some variable we don't know yet, right? So we call that X, you call that D, however you want to represent that. So we just kind of want to say X will represent my days. Right? So again, throughout the video, if you feel like you want to try it before I do it, pause me, try it, see if you're right. It's the best way to learn it. All right, next one says you start with $15. So we got $15. And save. So this time if I'm saving, I'm definitely going to be increasing $8 every week. All right, so this time the X here would represent weeks. I like dealing with the X, but a lot of people like to change those to D's for days, W's for weeks, M for money. However you want to do it, it's totally up to you. As long as you have a variable. Right, C says you receive your regular salary plus a 5% bonus on the regular pay. So you receive your regular salary, right? So I don't know what that is, so that's going to be some value I don't know, plus 5%. Now, when you're dealing with percent, you have to convert it into decimals. If you don't know how to convert it to decimals, remember Dr. Pepper. Percent to decimal, you go 2 to the left. So I'm going to take this 5 and go 2 to the left, and that now becomes 0.05. Bonus, all of your regular pay, which we let our regular pay be X. So always to note what you want your variable to be, so that the reader understands you know what it needs to be. Alright. D. Your cell phone plan allows 750 text messages. So we get 750. And you text 25 every day. Alright, so if we're trying to find out how much we got left, we could say minus 25 every day. And again, X would equal days. Alright, let's look at the next bunch. Evaluating expressions now. Okay. So now that we went from words to expressions and expressions back to words, let's actually evaluate. Evaluating is simple. I give you an expression. I tell you what each letter represents. All you have to do is plug it into the expression. So instead of a b squared, I'm going to replace b with 5. So that becomes 5 squared. We know more b because I plugged in that number. Minus 4, a becomes a negative 2, so I'm going to put that in parentheses. It still indicates multiplication, and the reason I'm using parentheses so I don't get confused and think that's minus 2. Times c, since I already had parentheses, I'm going to keep it going. And then you could do this one of two ways. You can type that straight in the calculator, or do it the way you need to do it, which is mathematically. So 5 squared is 5 times 5, which is 25, which again can be checked in the calculator. And then this minus here, it's going to be attached to that 4 when multiplied. So it actually becomes a negative 4. So negative 4 times negative 2 gives us a positive 8, because 2 negatives make a positive, and then 8 times 3 is actually 24. So then we actually add those up, that becomes 20, oh, not bad. Gotta actually add it up, which would be 49. And again, you can check a lot of this work in your calculator. Okay? There's your answer. So let's do the next one. Again, you can pause me and try it yourself. But I'm going to replace my x's with 3's. Again, I'm going to use parentheses just so I don't get confused. I could use parentheses here around 5 as well. So this becomes 3 squared. Replace my y with a negative 4. Now I'm going to do order of operations. Order of operations is PEMDAS. Parentheses is my p, so parentheses. Alright, so what's in parentheses, well, there's nothing I can do in parentheses. The next thing is exponents. Alright, so that's these little guys. So I got to work this out first. So 3 squared ends up actually being 9. Then I can multiply. So I can multiply this with this negative 9. So again, the minus sign will go with the 9. So it's negative 9 times negative 4 gives me a positive 36. And then I can add those up, and I'll get 39. Again, once you get to this point, you can always plug it into the calculator to check your work. My big thing is I like to see the work that you did to get to your answer. That's what I'm really looking for. The calculator is a great way to check your work to make sure you did it right. Because if you didn't, then you know you need to go and change some things up. Alright, so there we go. Again, looks real hard and confusing, but we're just going to replace our letters with what the values I gave you. So this becomes a 2, parentheses. My x is now going to become a 6 squared, minus my y becomes a negative 3 squared, all divided by 3. Again, using PEMDAS, I'm going to do what's in parentheses. And then in parentheses, I actually have exponents, so I have to do that first. So that's going to give me 2. 6 squared is 6 times 6, which is 36, minus, this is a negative 3 squared, so that's negative 3 times negative 3, which gives me a positive 9. But that minus here is from this original minus sign here. That's why it's not plus. And then if I finish what's in parentheses, that's 36 minus 9, which I believe is 27. Okay, and then 2 times 27 equals 54. Apologize for that earlier. Over 3, and then 54 divided by 3. Well, 3 goes into 5 one time with the remainder of 2, and 3 goes into 24 times 8 times, so that'd be 18. You know, a lot of these steps can be checked using the calculator. Alright, let's move on. Simplifying expressions. Alright, so now we're going to simplify it in its smallest term. What we're going to do here is we're going to combine like terms. So everywhere where I see an M, I'm going to put one line underneath it. And I'm going to add those up. So 8 plus 11 gives me 19M. And then my ones that don't have an M, I'm going to put 2 lines underneath them and combine those. So 7, or positive 7, minus 13 would actually give me negative 6. Or you type in your calculator 7 minus 13, you get minus 6. And then, yeah, that's all you have to do. So here, since this is a y squared, is that the same thing as x squared? So hopefully your answer was no. Y and x are not the same, so I cannot combine these guys. So this is actually its simplest form. You cannot go further. Now, if that was another x, yes, we could. But because those are 2 different letters, you cannot actually combine those. All right, so here, before we can actually combine, we actually need to distribute first. Right? Distributing means to multiply everything inside. So I'm going to drop down my negative 16m. Then 7 times 3 is 21m. Minus 7 times 4, which is 28. And now I can combine like terms. I got negative 16 and positive 21. So negative 16 plus 21 is positive 5m. And then my minus 28 has nothing to combine with, so it just comes down. There we go. All right, so let's look at the next one. Again, I have to distribute first. So 5 times 4x squared. So basically, the way you do that is do your numbers first. So 5 times 4 is 20, x squared, minus 5 times 2, which is 10, minus 16, plus 8x squared. Now I'm ready to combine my terms. So I'm going to combine my x squares. So I'm going to line underneath them. So that would be 20 plus 8, which is 28. Now here's the thing a lot of people mess up on. You try to say x squared, 20x squared plus 8x squared ends up being x to the 4th. It actually does not. When you're just adding like terms, the exponent stays the same. Alright, so this is like saying someone's last name was Smith, and you're adding it with another Smith. It doesn't become now two people Smith squared. No, it just means you have two people with the last name Smith. Alright, so you can think of it like that. And then my constants, those two lines underneath them. Negative 10 minus 16, so if I owe someone 10 and I borrow another 16, I now owe them 26, so that'd be negative 26. So again, you can type that in your calculator as negative 10 minus 16 as well to check your work. Alright. So let's finish it up then. So we got expressions and vocabulary. So name the terms, coefficients, and constants for each expression. So your terms are each one of these. Right, so that would be your 2x squared, your negative 3x, because the sign goes with the number, and 5. Right? Your coefficients are just the numbers. Right? The numbers in front of letters. That's let's distinguish that. So the coefficients are the numbers in front of letters. So that would be just your 2 and negative 3. And your constant is the number that does not have any letter. So in this situation, that is 5. Okay, so if you like to pause here and try to do B, that would be a good idea. Alright, so hopefully now that you've done B, let's see what our terms are. So we have this one, and this one. So they are negative 4yx, which is all one term, 8x, and negative 3. Again, remember the sign goes with the number. So my coefficients, again, are just the numbers in front of the letters. And since this is negative, it is negative 4 and 8. And then my constant, again, is the number that does not have any letters, which would be negative 3. Alright, so last example. So we're going to write an expression to model. The freshman class will sell pinwheels for peace as a class fundraiser. What is the total income after buying materials from the office supply company for a flat fee of $86? So we know we had to spend 86 bucks. So would we be adding that to something or subtracting that from something? Hopefully you said subtracting. Right? So we're taking 86, we're spending it. That's negative 86 bucks that we no longer have. And then they will sell pinwheels for $2 each. Well, this right here, that's our profit. So for each pinwheel we have, we'll sell them for $2 each. Okay? So there's your expression. And then if you were trying to make some type of quota, you'd say equal, maybe you're trying to make a profit of $100. So you put 100 there, and then we could solve how to figure that out, and we'll learn that later. Alright, don't forget to make sure all your notes are filled out for class tomorrow. And then go ahead and don't forget to post in the discussion either a comment or question about what you learned in this section. Alright, see you tomorrow.